Well, here we go again, folks. Theory lecture number 12, Engineering and Technical Graphics, entry-level class. In this theory lecture, we're going to talk about section views. And let me get situated here. Okay, I'll show you a part here. This part here, you can see it from the outside. Looks like this. I'm turning it this way, and then turning it upside down. You can see this, and so on. Looking at it from the outside, we do see it's a symmetrical part. So what does a section view do? What does a section view do? It takes this thing and it imaginarily cuts and removes part of the object to show interior detail of the object. Okay, so where this thing is cut, looking at it from the top, you can see it's a symmetrical part. Wherever this thing is cut, material-wise, that appears in red here. Turn a little bit of an angle so you can see it better. You can see there's quite a bit of complexity in this particular part. Okay, but wherever this thing is cut, there's either going to be positive areas, material, or negative areas, airspace, at the place or the plane that it was cut at. Okay, so why would we do this? Why would we take a part and open it up and cut it? Okay, why would you use a section view? Well, traditionally, section views were shown to basically show the interior view of an object, to make it cleaner and clearer to see, to eliminate hidden features. Now in the CAD world, a lot of times now, you take a cutting plane and basically cut it through an object to do measurements. Let's say to measure from this edge here to this edge here, to take this cross section here and to make a copy of that cross section and to put it into a Sketcher-based operation and create features from it. There's multiple ways you can use these section views. What we're going to cover today in this lecture is going to be the traditional section views. And the reason why we're covering this is more, just like with any of the traditional drawing things here, is more so you have an understanding of what they are. So if you ever see them on a drawing, you know what they are. And two, just to help develop some of your visualization abilities from this. So again, I'll show you a slide here that kind of explains them in a little bit more detail. But again, we're going to do several examples. But again, the operation you're saying, well, we got some kind of feature, some kind of part, and we're cutting this in half. So with that said, let's take this and zoom this out a little bit, actually out a little bit, and we have this particular part right in here. Okay, it is made up of a positive cylinder, another positive cylinder, positive feature here that goes across that supports it, a negative cylinder here, and another negative cylinder here. Now what they've done in here, they've placed an imaginary cutting plane in the object, okay? And so as you can see here, your line of sight is here. It'd be like you're standing right here. So if there's a spherical conic person here, standing here looking at this plane in this direction, and you can see that's shown by the direction of sight. Here's the cutting plane. And then it imaginarily cuts the object in half. Okay, so just like the front part of the other one is removed, in the section view sketch here, this part of the object will be removed. Okay, so then you will expose both the outline of the object, like we have here, the outline of the object, everything behind the cutting plane, where it touches the cutting plane along here, and in any kind of airspace in between. Okay, so then if we show a view of this, okay, right in here, then we have this top view right in here. There's the edge view of the cutting plane right across here. It's shown by a cutting plane line with arrows on the end of it. The cutting plane lines are thicker than normal sketch lines and making them more prominent on the sketches. They end with arrows. They basically have two dashes in them opposed to one dash. Okay, And then in this view here, it acts as if this front part of the object or the object on the opposite side of the arrows of the cutting plane is removed, thus showing you the inside view of the object. Okay, so again, we have then airspace here. We have airspace here where the negative cylinders go through. The actual cutting plane hits materials there, hits material here, through here, there, and there. Notice, though, in this section view, none of the exterior features are shown. Okay, so if you're looking at right here, you're not showing any of this interior feature. Okay, you're not showing any of that. Okay, and so these exterior lines are removed because they've been cut away. So they've been cut away. Looks like, again, this has been cut off here. Cutting plane line here. Opposite the cutting plane line is going to be your section view. Notice in these assignments you only have one section view and maybe either one or two other views. You will not create a front view and an additional section view. Okay. So again, we have the object here is cut completely in half. That's the theory behind the section views. Now, referring to some of your book readings in here, there are different types of things you should need to know about section views. Okay. Again, this section view here shows you, let me zoom up here a little bit. It basically, in this figure 8.1, it shows you the standard orthographic representation of the object, the cutting plane going entirely through the object, it's offset to cut different features, and then the section view. Notice in this section view, we do not include any hidden features with dashed lines. Okay? One of the reasons why that we do this to make these section view is the elimination of hidden features. So notice in this section view that any of the hidden geometry is thus removed. That's why you've cut the thing open. Okay. Cutting plane lines. You could see two types. Okay, you could see two types here again. Here's the cutting plane. Again, it's thicker. You could see one that it's a series of dashes this way, or two long dash, like a center line, with two shorter dashes and long dash. I would like for you to use this style of cutting plane. So again, refer to figure 8.2. In old drawings, you might see that there are several different styles of showing where the material and what kind of material there are. Okay, they're available. Again, most of what you're going to see within these are going to be materials such as cast iron, steel, maybe bronze or brass. But a lot of the other ones you can see in architectural applications, sand, earth, rock. Now, what has happened is CAD, these features here, these basically different section symbols were used exclusively until right around between the First and Second World War. Then they simplified the drawings into basically typically the cast iron type of metal representation. But now with CAD, you can fill these things in easier, so you're seeing a lot of reappearance on these, especially in architectural areas here. Again, looking down here, there's a variety of ways that you could put the cutting plane. You know, you could have it vertical, showing a frontal view. You could have it horizontal, showing a top view. You could have a profile in this orientation showing a side view. But just notice that your arrows are always going to point the opposite way of your cutting plane. Okay, so if I zoom up on the middle one right in here, which is the same as the other ones, your cutting plane line, your arrows are always going to be the opposite. So it's pointing this direction, thus this is moved, that's what you're seeing. Okay, that's your line of sight. Standing here looking at this, and that's what you see. You want to try to avoid, you want to try to keep your cross-hatching lines neat, okay? Try to keep them approximately the same, okay? You want to try to keep these things that are not running either perpendicular or parallel to any of the object lines. It gets confusing. This is an example of an assembly section where different parts here are cross-hatched in different areas. So again, you have a cross-hatching here with a different part here. This is like a thin washer, a gasket in there. You have some kind of fastener in here shown. Okay. and again, airspace at that point. Again, just another example of an assembly section here on 8.8. Okay, so again, your crosshatch lines for this component are going to be different from this one. Again, notice that this and this are the same part, this and this is the same part, but these are then different parts. Typically, in all sketch applications, you'll show everything behind the cutting plane. But now with CAD, you'll find out there's a lot of times you'll just want to grab where the cutting plane is and leave the stuff behind it off, because you might just want to use this section to do something with it. But for what we're doing here, you want to show all the features behind the cutting plane. Typically, you should not use any hidden features in a cutting plane with a dashed line, but there may be times when you have to. But I'll say within the context of this course that we won't. So again, they're showing this dashed line in here to show that it's cut out, okay, to give you an idea here. You want to refer to these ribs and sections, or ribs and webs in here, okay? Ribs and these webs in here are not cross-hatched. Okay, it would make this thing look like it's conical if there was cross-hatching here and here to make this thing look solid if there's cross-hatching. So things that are thin, such as these, are not cross-hatched. Different types of section views. We've looked at this before. And this one here then is a full section. The cutting plane goes entirely across the object, okay, exposing the interior detail, airspace here, and a material all across here, and airspace where the hole's at. A half section. A half section is showed in Figure 8.13. In Figure 8.13, there's a mistake on this particular figure. There should not be any dashed lines. You should only show the exterior view of the object. The reason why is now here's your cutting plane here, going up. It's a half cutting plane. It just comes over here and takes a quarter of the object away. This is all shown as interior. This is all shown as exterior minus the hidden features. You're showing all this hidden stuff over here, and it's split down the middle with a axis line. So interior view, described by the cutting plane, exterior view where the thing has been cut, a half section. Offset sections are basically offset to catch different features of the object. Okay, they're offset to catch different features of the object. Notice in this case here you still have a full section, but it goes from here, offsets to catch this hole and this area in here, and here's the resulting geometry here. So you're trying to basically move the cutting plane through here to catch features. Notice where this cutting plane turns, there is not a recognition of that in this particular view. Conventional break lines can be used as in Figure 8.15. Basically, the thing is real long. You can break it off here and here and show this revolved section. In other words, they've just taken this thing and moved it in here, and then showing you what this view of it looks like. This is not a section view here, and then showing the section view of it right in here where it's circular to this hexagonal or octagonal representation right in here. Again, remove sections here. We had before. Again, this one should be crosshatched. Okay, the remove section here, again, just showing you different features of the object. Again, in here, down at the bottom, with this one showing then where the cross section here. Notice that the section line is named in this particular object. It's named AA here, and my resultant view is labeled AA. And this is typically done to show either multiple section views, scaled section views, and so on. So there'll be times where you'll see that the view is actually named by the cutting plane. A broken out section. A broken out section is a section view that does not use a cutting plane. It just is using a conventional break line. So they've just broken a part of this object out in here, cross-hatched here. There's no cross-hatching in the middle here where the hole's at. Okay? And then the use of conventional revolutions. Okay? What happens here is in Figure 8.19 and also on both sides. And in either case, it acts as if this support feature, this rib, is moved into this position. It makes it easier to read. Okay, you would have multiple, for this example here, you'd have multiple holes. So it's moved into the normal or 90-degree angle and then cross hatch. So remember to look at figure 819. Okay, so that's kind of an overview of the different types of section views. And now we're going to look at some examples here. First off, I want to look at this particular example here. Okay, zoom out here a little bit. You have a simple part. Okay, this is one of the parts that's in the back of the book. And then we want to show this thing then as a section view. Put my dashed lines in here, or my center lines, excuse me. So the logical place to cut this thing would be right in the middle. Okay, so again, I'm coming over here. I'll extend this out a little bit. Put a arrow here. Extend this out over here. Put the arrow there. And now what is happening now, what will happen, is this cutting plane, it's going to be hard for me to put the gaps in here, but again, there should be these gaps in here. This cutting plane here will cut this, imaginarily cut this part of the object off, exposing all the interior views. Well, now, these lines here become object lines. You can see these. Again, remember, no, in the context of this class, will be no hidden features. So these become exposed, thus they go from being a hidden type feature, in this case, a limiting element of cylinders, to object features you can actually see. Wherever the part is cut by the cutting plane, right in here, right across to there, right across to here, and here will be, will show with cross-hatching lines. So in this case here, I'm going to come through here and I'm going to start to cross-hatch this here, here, and there. Again, I'm going to try to keep it same angle, same direction. Be neat with it. Okay, I'm off here a little bit, I can see already. But again, where there's material, you don't fill it in, you don't make it solid. So again, let me just try it over here and visualize this, trying to stay at the same angle here. And again, one half the object is cross-hatched, just the same as the other half of the object here. And again, let me show you some good examples and some bad areas. These are pretty consistent. These get a little bit spaced out. So again, you want to try to stay consistent with these things. You don't want to confuse somebody as if they have two different types of cross-hatching, because if you had a cross-hatching here that was different than this one, then you're assuming this is a different part, which is not. This is actually one single part. So again, place the crosshatch, place the cutting plane in there. Visualize what's going to be cut. Anything that is not cut is airspace. Remember to put the lines behind the cutting plane because you still have material back there. And since these are all cylindrical parts, you still have to include the center lines representing the axis of the cylinder. So again, all that needs to be done on that particular one there. Give you a chance here to just kind of visualize that thing a second and look at it. And then we'll go to another one here. Give you a few examples. Another example here. In this case here, we have, and I've left lines off. There should be an object line across here, but I'm going to basically cut some of this thing off. I'm going to put a full cutting plane across this thing. So again, I want to put my cutting plane right in here, right across the object here, and then also right here. Now what happens? It acts as if these two support features are moved into this position that I have here in this colorish red. So it's act as if these things are moved into this position. Moved to there, that one's moved to there. It acts as if these holes are moved into the position right over here. So then when you cross-hatch it, okay, when you cut this thing open, notice that then these features have been rotated. The rib is rotated into this position, the holes are rotated here, and I've cut entirely through the object, thus exposing the limiting element of this cylinder here. Okay. Again, a limiting element of this cylinder here and here, here and there. Now, if you remember, the exterior view has been cut away, thus the line going across here is no longer there. You will not include a hidden feature on that either. And also, if you remember from figure 819, these things are revolved into position that these ribs will not be crosshatched. So then what is crosshatched on this one is just these areas right in here. So I'm going here and there, 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 there. Again, the same thing on the other side, same direction. Because remember, you're looking at the interior of the object. This is all material through here. So there we have the resultant view. The holes have been rotated. These two ribs have been rotated. Okay, showing you then material here, rib that is material, but it's not crosshatched to keep it from being confusing, because that would make it look as if it's like full conical part, but it's not. It's just support features. Okay, so there's an example of, two examples of full sections. Again, a cylinder with a cylinder here with these support ribs and the holes in there revolved into position. So let's look at another example here. Let's look at another example right over here. Okay, now let's look at this part right here. I'm going to lay the part on here. Okay, it's a symmetrical part. So it'd be nice to be able to show part of this thing as being interior and part of it being exterior, which would lend itself well to a half section. Again, if we look at this thing from the normal view of it, it would appear, so I fumble around here and get this thing over to you, it would appear, scooting it over a little bit, here would be your views of it. Let me zoom out a little bit. Okay, so it's got a basically cylinder here, bigger cylinder at the bottom, some curves in here, a cylinder that goes through in the object, and then it's got this open area right in here. Now looking at this now, looking at this here, you can see, I don't know if it's going to be showing up that well with this particular object. Let me see if I can turn an angle here. But again, this is material right through here, going through here. Okay, here's your hole in here. And this is basically a chance to show this thing as a half section. Exterior view here, interior view here. So now let's go ahead and create this part, okay, looking down from here, you know, kind of getting an idea what the part looks like. So now we want to create this part as a half section. Remember, in a half section, a cutting plane starts here, and there's only an arrow on one end of it. So it starts over here, goes over here, and then goes up to right here. One arrow. If you did put another arrow, it would have to face in the same direction, but again, that is too much like work. Okay? Now, this part of the object has been exposed, thus on the other half, you will show the exterior view. Basically, the line coming across here, right through there, and then you would not show any of the hidden features. So those would not show up on there. And you're trying to show what this thing would look like on half of it on the outside, center line dividing it, and then what it would look like on the inside. Okay? So now I'm going to go through here and say, well, we have this area in here, wrapping around, and then we have the hole in here. And then these three dashed lines wouldn't be in that location either, because you just have solid material there. So again, cross-hatching this thing out. Cover these things up a little bit. And then there is the half section. Half of it exterior view, half is interior view, no hidden features, divided in half by a line of symmetry or center line. Okay? And that's the resultant section view. Okay, it gives you a good idea from what the outside looks like and what the inside of this feature looks like. So again, an example of a half section sketch. Another example here. Let's describe the geometry on this one. You have a rectangular base here that's got the corners rounded off. You put some of my center lines in here. There, 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 and there. Okay, center line right here. Center line out to here. Okay, now what we want to do is we want to show this object as best we can with an interior view, but we have to strategically place the cutting plane. We're going to use an offset full section. An offset full section. So now what we're going to do is you go through this thing and do it a couple different ways, okay? So the first one I'm going to use in red, I would come over here and I would go through this hole. I would turn here, follow this thing around through here, come up, and go through the other hole here. So there's the first option. Thing is in kind of the red color. So again, it's going over here, turn, going through here, turn down, and going through there. The second option would be to go through here, different color, up, across, and down, over here again, and up and across here. Now you're going to get two radical different answers to this problem if you do this. So I'm going to zoom up here again so you can see the way I put these cutting planes. And the red one goes here, turns, goes through the cylinders, turns, goes through here. Okay? Then the purplish colored one goes here, turns, goes here, goes through here, turns 90 degrees, and goes back through here. Now remember, whatever is on, since my arrows are pointing in this direction, towards the back of the object, whatever is in front of that cutting plane will fall off. So again, on this example, notice that all this area here would be removed from the object. Thus, you would keep these support features. Now, I'll scoot this up just a little bit. You would keep the support feature here because it hasn't been cut off. If we go to the back example and we cut through here, then this support feature is going to be removed. So you want to think about where you want to put these cutting planes before you go through it. So the best option on this one would be take an offset cutting plane, go through here, turn it, go through here, turn it, go through here, and up. That way you don't remove either one of these ribs. And remember, these support features are not crosshatched. You've used a full offset cutting plane. Remember, here's the offset here, going back, offsetting towards the front, and so on. There's no change of plane where it offsets, so now this has been exposed. These are now all solid lines. Right through here. And then you crosshatch, everything's touched by material. So again, through here, through here, again here, there, 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 there. Don't forget your center lines in here. Don't crosshatch the ribs. Don't crosshatch where there's airspace. And that's the resultant section view geometry. Again, the reasons is to show interior details without the use of hidden features. It's explain things easier, visualize. Again, you probably may not be doing that many section views per se, but you'll probably have to read views, section views of particular things that may already be in existence. So you need to know how to understand to do these things. You need to know how to do these particular ones. And probably the biggest thing you have to do with these things is the actual visualization of the geometry itself. That would probably be the most challenging parts with these section views. But with a little practice, following the conventions, you should not have too much of a problem doing the section views and working with them. So with that said, I am going to cut this lecture off And I hope that everybody, again, has a good evening wherever you're at in the world, and everybody's safe, and your friends and families are safe, and the weather's nice like it has been here. So everybody have a good evening and good night.